All right, we are going to look at angled launch and trying to find the range of something where it ends and starts at the same height. All right, this is known as a y naught equals y problem, and we're going to try and find range for that angled launch. So here we might have a ball, golf ball, whatever you want to be, shot at 20 meters per second at an angle of 15 degrees. We want to know how far is it going to travel, and again, we're going to neglect air resistance in this situation. All right, so we have a two-dimensional motion problem because the ball is moving both vertically and horizontally. So I list my variables, and whenever I have 2D motion, my times are the same. Secondly, this is projectile motion because the object is moving in the x direction and in free fall in the y. So my acceleration in the x is 0 meters per second squared. Again, because we're neglecting air resistance. And in the y direction, it's going to be negative 9.8 meters per second squared because the only thing acting on it is gravity. With a 0 acceleration in the x, the initial and final velocities are going to be the same value. And I'm going to be using equation number 2, so x equals x naught plus v naught xt plus the 1/2 at squared term goes away because the acceleration is 0. Now, we also have an angled launch. Okay, so for an angled launch, I need to resolve that initial velocity into components. So I would have the initial velocity times the sine of the angle for the opposite side and v naught cosine of the angle for the adjacent side. So we're going to use those sine and cosine functions. All right, so we can put those in here. So I have v naught cosine theta and v naught sine theta. Now those do have numbers, but I'm going to leave them like that for now just to kind of play with something for you. The other thing that comes up is because it's a y naught equals y problem, we choose our start and our end because they end at the and start at the same height. We're going to call that y equals 0. And the leftmost point is x equals 0. So it starts at 0 meters and 0 meters, and it ends at 0 meters high. Now, this right here has a big benefit. It tells me about the final vertical velocity. And you can think about it as there's some symmetry here. So that symmetry is that this side on the way up takes half the time